Good afternoon, Scrutiny Stars. It's Mr. Glenn, and we're going to talk a little bit about Geometry Lesson 2 today. So you remember that Miss Waggy introduced the formula for area of a triangle yesterday. I'm going to review the area of a square and a rectangle. After we go through that, then we will do a few sample problems. So let's take a close look at what Miss Waggy introduced you to yesterday. We've got two figures on our screen here. So we've got a rectangle. So let's talk about this rectangle first. I'm going to take a straight edge and divide this rectangle into two equal-sized shapes. And this is pretty easy to see here. We've got an orange colored triangle in the bottom, and remember, the most important part to think of is that if we split a geometric shape into two pieces and we do it right down the middle, so if we would have done it the middle this way or the middle this way, we went diagonally down the middle. Both of these three-sided shapes, the blue and the orange, they are both the same size. So I just want to review with you that we all know that this lower area down here, this line segment from here to here, this dimension of this rectangle is 2.5 yards, just like the top edge, right? Because we know that this side is the same as this, right? So we know that the base, which is this right here, times the height, how tall it is, right? This determines the total area. So area equals the base times the height. Now look at this. We have a triangle over here, and Miss Waggy had introduced the formula for the area of a triangle, and I'm hoping you guys are looking in your notebook right now at what you did yesterday, right? So if you look in your notebook, you can find the spot where it says area of a triangle equals 1/2 the base times the height. 1/2 times the base times the height, or base times the height divided by 2. Any way you want to cut it, it's the same thing. So take a look here. We know that a rectangle divided into two pieces, two equal-sized pieces, and the formula for rectangular is simply base times the height. So is it not true that if the blue triangle is 1/2 of the whole rectangle, just like the orange triangle is 1/2 of the whole area, would it not make sense that the area of a triangle is 1/2 the base times the height? Okay? I think that's pretty easy to see graphically. I'm going to zoom out here. I got my paper cut off. There we go. So another thing I wanted to point out is you guys are welcome to use a calculator today. For the last few weeks we've been able to use a calculator. So let's take a look at the first problem where we've got 1.45. So we know that 1.45 times 2 equals 2.9, and then we need to multiply that by 0.5, which is equivalent to 1/2. So basically what we did in the first problem, we have, for the triangle, we have 1.45, which we got, the formula is 1/2 times the base is 2 times 1.45. So we know from PEMDAS that this is area equals 1/2 times 2 times 1.45. So if we go from left to right using order of operations, what's 1/2 times 2? That's 1. So that's why our answer is 1.45. Because we know that 1/2 times 2 is 1, and 1 times 1.45 equals 1.45. Alright? So on the other side, we've got area equals base times the height. We've got, we got 2.5 times 1.45 and that gives us 3.625. So we just do 2.5, area equals 2.5 times 1.45, and our answer is 3.625. Alright folks, that's our quick review for the day. Let's take a look right here. I'm going to read you a comic, so this is kind of interesting. If you scroll down, you've got, should have lesson 2 for today open. So let's read this comic here. We've got a scientific looking guy, and I guess maybe he's a mathematician. And he says, "By Jove, Donald, I do believe that quick review question was way too easy. We've got to come up with something better. Like this one. How would you find the area of this figure, my dear brother?" And look at this. This must be his brother down here, because he just calls him, he does what you guys say, a little bit of the IDK. IDK, bro. My dear, dear brother. I always told Mother we weren't identical twins. Such a simpleton. Righto, chaps, help my brother along. What are your ideas for finding the area of this new figure? So let's look at this thing. Do you see any way we can divide this into two shapes that we may be very familiar with? So maybe if we look up here at the top, do you see two shapes that we could divide this guy into? So I'm going to take out my straight edge again, and I'm going to start right here because I see a rectangle and a triangle. You guys see that? So I'm going to color this triangle orange. You see that guy? Pretty easy, right? So every time you look at a complex shape, think of breaking it down into two shapes that you're familiar with. Remember, all year we've been talking about, hey, is there something that I've seen before? Is this something that I've done before? So right now we've got a blue rectangle and an orange triangle. We know the dimensions of the triangle, and if I go like this and just cover this guy up, we've got a rectangle that's 2.5 times 1.45, right? So if we go like this, 2.5, so the area, I'll just do this in blue. The area of the blue part is 2.5 times 1.45. Now, you know what's really strange? We've seen these numbers right up here in our quick review problem. 2.5 times 1.45 equals 3.625. So let's take a look down here at our triangle. How big would our triangle be? If we know from here to here is 4.5, right? We know all that distance from there to there is 4.5, right? Everybody knows that. We can see it right here, right? But we know that this section from here to here is only 2.5. So if the big part is 4.5 and the small part's 2.5, what would it be for this section right here? So let's look at this red section. 4.5 minus 2.5, that means this must be 2.0, because 2.0 plus 2.5 would give us the total, right? So 2.5 plus 2.4 equals 4.5. Everybody see that? Very cool. So now we're going to take this, which came out to be 3.625. We just need to find out what is the area here. So the area of this triangle, we know the base is 2, and look at the height, 1.45. Does this look like anything familiar? Well, let's look up here. Appears to be the exact same dimensions as this triangle up here. Right, folks? So we've got a base of 2.0, we've got a 1.45 for a height, and that's what we have right here, 2.0 for a base, 1.45 for the height. So let's take a look we're going to go back right here. I'll bring this down. The area of the orange part is equal to 1/2 times 2, because we have 2.0 right there, times 1.45 equals 1.45. So folks, if we have the area of the second part is 1.45, we take 3.6 and we add it to the 1.45, then our total area is going to be 3.6 plus 1.45. And remember, we're able to use a calculator nowadays, so please feel free to take out your calculator. I'm going to do 3.625. We're going to add 1.45, and we're going to get 5.075 as our total area. 5.075. Everybody see that? Remember, if you have any questions, please type it into Google Classroom, and either myself or Miss Waggy will be happy to answer your question, alright? So we've got this, and last but not least, we've got these weird abbreviations right here. So we've got something called units, right? And these are yards. So if we have 2 dimensions, because we have a height and we have a width. So we have 2 dimensions on this side, so we need to add our yards to our answer, and it has to be yards squared. So our final answer is 5.075 yards squared. Yards to the second power. Okay, folks? So let's take a look at our next problem. We've got problem number 1 here, and I'm just going to block this guy out so we can take a look at problem 1, and we are going to make it easy to concentrate on problem 1. So same thing, they say we want to find. So before we get into that, let's talk about problem 1 is brought to you by none other than the #1 candy, the #1 candy bar in America. So let's take a look.
Hershey Bar, one of the old-time greats.
Alright, thank you folks over there at Hershey, Pennsylvania. So let's take a close look at problem number 1, brought to you by none other than Hershey's. Alright folks, once again, we've talked about this before. We're looking for shapes that we're familiar with. So right off the bat, I can see a triangle. We're going to have a blue triangle here. And I can see, I'm sorry, I said blue. We have a red triangle, and we're going to have a blue rectangle. So this is very similar to our sample problem that we just did. So let's take this apart now. We are going to break this down into 2 separate problems, and then we're going to add them together, right? So here we go. Here's our first triangle. We've got 3.4 meters by 1.74 meters high. So let's take a look. We know from Miss Waggy yesterday that the formula for the area is 1/2 times the base times the height, right? So if I were you in your notebook, I would just draw the triangle next to a rectangle. You write 1/2 base times height. When we figure out the base, we figure out the height, we're just going to plug those in. So area equals this. So gee, look at this, 3.4 meters from here to here. This corresponds with this section right here. So I'm going to say that the base is 3.4, so we're going to have area equals 1/2 times 3.4, because we got that from right here. And then that's times the height, and the height is 1.74. So once again, we have area equals 1/2 3.4 times 1.74. So again, calculators are legal right now, folks, at the end of the year for 6th grade. So we've got 3.4 times 1.74 equals that, and we're going to multiply that by 0.5, which is 1/2, and we got 2.958 for the red part, equals 2.958. And these are meters, so those are going to be meters squared. So the second, we got the area of the red part sorted out, and we know that's 2.958. So I usually write it right in there. So we know the red part's that, so let's solve for the area of the blue rectangle. So the area of the rectangle, we know that's simply base times the height, but wait a minute. We don't know how long the base is. We know the height, so let's just do area equals base times height. We're going to figure out the base. We know the height is 1.74. So how do I know if from here to here is 3.4, and we know from here all the way to the end is 7.5? How would I figure out how far it is from here just to here? The blue area. We know the red plus the blue is 7.5, so what would just this blue area be? We know this is 3.4 over here in the red zone. So we got 3.4 for the red zone. So wouldn't we take 7.5 as the whole and subtract 3.4 to find out the blue zone? So again, you can use your calculator. 7.5 minus 3.4 will give you 4.1. So we know this number is 4.1. So we know area equals 4.1 times 1.74. That's going to equal, again, it's that time of year where we can use a calculator. 4.1 times 1.74 equals 7.134. And remember, we have two dimensions, and these units are meters, so they're going to be meters squared. So we have the red area is 2.9, the blue area is 7.134, and we need to add those together. So 7.134 is already in my calculator.